also going to install it at the bottom of the docking tunnel, right behind the Nat Geo microphone. That's pretty central. So instead of putting it on the DUs, it'll be at the bottom of the docking tunnel, yeah, opposite the windows.
Copy, checking. And Jeremy, we are good with plugging the acoustic monitor into the USB charger, and we're good with your install location.
Okay, perfect, thanks. And then at nighttime, if we're doing docking camera tonight, which I suspect we are, then I'll transition it to PCD power.
Checking. And Jeremy, we like your plan.
This is Artemis Mission Control in Houston, Texas. You just heard the conclusion of the DPC, the Daily Planning Conference, when the ground team here can relay up any status updates or daily planning for the crew aboard Orion. And the crew has an opportunity to ask some questions as well. Some of those reports may have sounded very simple or menial, but this is the first flight of humans aboard the Orion spacecraft, and so every single detail, even about normal daily tasks, is very important to this team as they prepare for future Artemis missions to the moon. This crew is truly learning and testing everything aboard the spacecraft to make sure we have good systems and good plans for our future explorers. Coming up in about 15 minutes, we will have the ship-to-ship call when the Orion crew will be able to speak directly with the astronauts and cosmonauts living and working aboard the International Space Station.
Okay, Houston, the acoustic monitor is set up and it is recording, and I will take a photo of that for you. I think I'll just take the photo on the iPhone and put it on PCD3 for you, if that's okay, because we're using the D5 right now for the PAO event.
Copy all, Jeremy. We like it.
You're looking at a live view inside the Orion spacecraft of the Artemis II astronauts. Closer to the camera is Commander Reed Wiseman.
And Integrity Houston, just a reminder for the upcoming ship-to-ship call, it's going to be the OE1 microphone, not the handheld.
Again, you're looking at a live view inside the Orion spacecraft. Victor Glover in the background, pilot of Orion. They will soon be speaking with the crew aboard the International Space Station. The International Space Station has been orbiting Earth with humans living and working aboard it for over 25 years now. Current crew members are part of Expedition 74. That includes Roscosmos cosmonaut Sergei Kutsverchkov.
And Houston for downlink on the 4K encoder, we only need the video, not the audio.
Okay, Sam, thanks for that. We have restarted the stream with audio off, and hopefully you're getting a good image.
We copy the audio, and we see a great image.
Again, the Expedition 74 crew currently living aboard the International Space Station: Roscosmos cosmonaut Sergei Kutsverchkov, NASA astronaut Chris Williams, Roscosmos cosmonaut Sergei Mikhaev, NASA astronaut Jessica Meir, NASA astronaut Jack Hathaway, ESA astronaut Sophie Adeno, and Roscosmos cosmonaut Andrei Fedyayev. This is Artemis Mission Control. We are preparing for the ship-to-ship call from Orion to the International Space Station. This will be an audio-only event broadcast at this time due to bandwidth, but we expect to download the video from each crew later and share that with you. Please follow NASA on social media at NASA and at NASA Artemis, as well as the International Space Station, to make sure you can see all of our crew members talking to each other while in space. While the crew aboard the Orion spacecraft is coming back to Earth after passing more than 250,000 miles away from our home planet, the crew aboard the International Space Station is about 250 miles above our planet.
Integrity, this is Houston. Are you ready for the event?
Integrity is ready for the event.
Station, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is the International Space Station. How do you hear?
Space Station and Jessica, we have you loud and clear. How about us?
We have you loud and clear as well, and we have BME TV up, so we have a view of you right now, and it is making us so excited. We feel like you're here with us, and this is really just making our entire week right now. We've been following along and have seen the incredible photos and heard some of your observations that you've been reporting.
Jeremy, we have been waiting for this like you can't imagine. Let me go check on our PFD. We are 201,726, now 25 nautical miles from planet Earth, which is just hard to believe. The scales are impossible to believe. And for the run of show this morning, I figured I'll say a quick hi, which I have done. I'll hand the microphone to fellow chump Jeremy. He can say a quick hi, and then we'll let you three 8-balls just get on with it. Yeah, thanks for giving me like a tiny bit of microphone time before the 8-balls get after it. But it's such a pleasure to be spending a little bit of time with our colleagues in space, and we talk so much up here, or we try to anyway, emphasize how important the work is that we're all doing in this program to do the types of things that get us ready to get back on the surface of the moon, and like the administrator was saying yesterday, onto Mars. And so we just appreciate you, and it's fun to be up in space with you at the same time.
We are so excited to be up here with you, and we had a couple of questions. We are wondering, we know how fortunate all of us are as humans to come up here and look down at the Earth from above. Every astronaut that comes to space remarks on that, and we really wanted to hear what that felt like, how different that felt now from your new perspective around the moon.
Well, I'll start by saying we do miss the ISS. The views there are awesome, being able to see specific places, being able to see your home specifically. So y'all's views are absolutely incredible, and I miss them every day almost. The thing that changed for me looking back at Earth was that I found myself noticing not only the beauty of the Earth, but how much blackness there was around it, and how it just made it even more special. It truly emphasized how alike we are, how the same thing keeps every single person on planet Earth alive. We evolved on the same planet. We have some shared things about how we love and live that are just universal, and the specialness and preciousness of that really is emphasized when you notice how much else there is around it.
Really amazing to hear. You know, it's been an incredible time getting to be here on station. I know you guys have had a lot of that same experience, and we were super curious. You know, like what you're carrying forward from your time training for and flying on ISS to the moon.
Well, the Navy pilots were carrying on, so I'm the only one that heard the question. I'll go ahead and respond. Actually, Chris, it was awesome to watch you and Jessica go out on a spacewalk. I was lucky enough to sit console for your suit up, and I was just filled with pride, but it also really reinstilled in me those flight operations principles that we live by in a real-time, high dynamic, and risky environment. So having that kind of impressed in my mind right before this flight was huge. And basically every single thing that we learned on ISS is up here. And then, of course, there's the funny and practical, how to eat, how to do silly things with water, how to flip around. We're bringing that with us, too.
And I just got to add, C-Dub, right before you launched, you said you can't wait to talk to us on the space to ground, and it is happening, brother. I cannot believe it.
Face to face, we said.
Yeah, I can't believe it. I mean, I remember having coffee and sitting with you guys just before I left to fly up here, and it's just so awesome being able to talk to you right now. It's such a special opportunity.
And we had another question, because now you're in a little capsule that is your home, and although this is a test flight and so everything is new, what surprised you in your journey so far? We know that Weed really likes it up there.
It's really great to hear your voice up here. I can't tell you how fun this event is for us. I hope you guys are enjoying this as much as we are. I don't mean to give you such a short answer, but I can truly say everything. From the core stage ignition, solids lighting, to getting into a new orbit, even right after 8 minutes of boosting on the core stage, to then the translunar injection, to flying by the moon. This entire journey has been interesting, but also applying some of the lessons from station in a much smaller volume, how we move around and eat. Those things have also been surprising, because the difference between ISS and here is we don't have another module to deconflict, and so everything we do essentially starts with a spatial conflict, and we have to take the time to work it out in every activity. And so we've been just having fun working through that.
Thank you so much, Victor. That was such a good answer. We laughed all here hearing your answer. Thank you so much.
All right, my turn, and I'm excited to talk to you guys. It's been awesome up here. Being rookie it's been such an awesome experience, having a great crew. I know you guys have a tight bonded crew as well. Jessica dared me to grow a mustache all during training, and I came through on that. So I'm kind of curious what kind of fun you guys had in your training and on your flight here that's been keeping you guys smiling.
I just had a process escape on my water training up here, and I left the PWD valve open a little bit too long. Now, I will say, I'm not the only one to have done this, but I do have the record so far for the largest process escape on the water training failures.
Well, we can tell that you guys are definitely experiencing moonjoy, and I feel like even we are experiencing moonjoy right now. I think this also sounds like a great band name, so we can't wait for you to drop your first album.
I got a question for you, but the quick story I wanted to tell you is you were asking what it's like here compared to International Space Station, and I'm just going to relate a very quick funny story. Heading into our translunar injection burn, we're coming out of 38,000 miles, coming down to a 100-mile perigee to do that burn, and when we were about 5,000 or 6,000 miles up from the Earth, looking at the entire Earth just growing rapidly in the window, Jeremy turns around to us and goes, "I'm not sure, I think we're going to run right into it." And we were all dying laughing. And it was the most fascinating thing to watch, that Earth grow. And we actually ended up TLIing on the upper half of the Earth, and we thought we were going to TLI on the bottom half of the Earth. Like, that is the perspective we had, and then the vehicle reoriented and we went. So it is crazy up here, and it does bend your mind. So question for you guys, I'm looking around the Integrity spacecraft right now. We're rehydrating some sweet and sour chicken. We've got some Kona with cream. We've got some butternut cookies. Butternut squash and spicy green beans. So it's all the same food. We want to know, what are you eating, and we're going to mirror you today.
So I had spicy green beans for lunch, and I've been loving seeing all of the things about you guys having the same food. It's fantastic.
I had a mango salad this morning. I think you have this on board too. Oh, Nana, I know you love that mango salad just like I do.
Yep, there's a mango salad on the deck right now.
Well, I hope I'm not talking over somebody, but I wanted to say a couple things to my Astro sister, Jessica. One, sorry to steal your next spacewalk day, everybody, but thank you for cheering us along anyway. And Jessica, I always hoped we would be in space again together, but I never thought it would be like this. It's amazing. Congratulations to you on being commander, and I hope you have an amazing rest of your trip in space.
Thank you so much, Christina. I totally share all the same sentiments, and I'm so happy that we are back in space together, even if we are, a few miles apart. We like to joke about that up here, too, because everyone's talking about the records of the distance, and we ran to the far end of the space station when you guys were on the other side so that we could claim we were the furthest away from you in that moment. Love all four of you so much.
We were doing the same shenanigans here when we got to the furthest point from the moon. I tried to get to the furthest point from Earth. I tried to get to the furthest point in the spacecraft, and my crewmates were clawing me down. And I know that's a joke. We were busy doing science, but we had that same conversation. It was a lot of fun. I don't know how much longer we have here, but from the four members of the spacecraft Integrity, we really want to just say our deepest appreciation to the 7 members of the International Space Station, and this has been a true treat. It takes the entire world to do amazing things like this, and to get to come together as this group of people and talk for just a minute at these distances. We are all off the planet Earth right now, and we're all going to go home to that planet, and that is a very special thing. So thank you all for tying in.
Thank you, Reed. Well, beautiful words, and yeah, from here.
And Integrity Houston, ISS is doing a teacher's handover. They'll be back with you shortly.
We are loving all 4 of you from here, from the space station in low Earth orbit. We'll keep the fires burning here.
And we'll keep carrying the fire. Thanks, guys. Over and out.
Thank you, guys. International Space Station, over and out. Made our day to talk to you.
Thank you to all participants. Integrity and station, we're now resuming operational audio communications.
My goodness, Houston, that was amazing for all 4 of us. All smiles up here. Just thank you so much for enabling that. That was very, very special to this crew.
Reed, we were happy to do it. You should have seen all the smiles in the control room, and we had a packed visitors gallery, and everybody was grinning up there, too.
Man, Stan, that just made us all cheer up here as well. That is just such a cool thing for the agency, the nation, and the world. What a neat moment.
And here we are experiencing it.
This is Artemis Mission Control at a mission elapsed time of 5 days, 20 hours, and 19 minutes into the flight of Artemis 2. You just heard the voices of the Artemis 2 crew and the crew aboard the International Space Station speaking with each other while both are in space. A ship-to-ship call. We are excited to share that video and audio with you later on today. You can find that on NASA's social media. This is Artemis Mission Control, and the audio you just heard of the crew aboard Orion and the crew aboard the International Space Station speaking with each other. Again, we are going to downlink that video, and we will let you know when that is available. You can follow NASA on social media and the International Space Station as well. We can't promise a time frame when we'll have that video down for you to enjoy, but once we do, it will be fantastic. The International Space Station is now flying 267 statute miles just south of Africa. Meanwhile, the Artemis 2 crew is flying 231,793 miles away from Earth. Coming up next for the Artemis 2 crew is a conference with the science team. They will be reviewing what they saw yesterday during their lunar flyby, sharing any findings or interesting information with the science team while it's all still fresh for the crew members. Of course, they have quite a lot of audio recordings that have been downlinked to the science team, and that team has been reviewing and will continue to do so to help them understand what the crew saw and formulate new thoughts about our moon. During the crew's post-lunar flyby conference with the science team, you'll hear them speaking with Dr. Kelsey Young. You heard Kelsey's voice quite a lot yesterday as she was communicating with the crew aboard Orion Integrity. She and her team in the science evaluation room were helping determine even what some of the features were that the crew members were seeing but couldn't quite identify.
Houston Integrity, where did you want to do that flyby conference? On OE1 or OE2?
Jeremy, around Earth 1, please, and Kelsey standing by.
Okay, Kelsey, fire away.
Integrity Science, I have to start with a giant wow. Our whole lunar science team and the broader science community has been pouring out positive feedback and gratitude, so know that what you did yesterday really made a difference scientifically. Also want to say the science team has confirmed the locations of the proposed Integrity and Carroll craters, and it was such a powerful moment here for everybody listening and following along. And then also, just before I dive into the list of questions questions. We heard both Christina and Victor yesterday commenting that being able to discuss with each other amongst your crew, taking things from observation to inference to hypotheses, really added scientific value, and so we'd love to build on that here. So we'll ask specific questions for you guys, but please treat it like a discussion as we heard you yesterday that enhanced value. When you're ready, I'll dive into our questions.
Okay, Kelsey, love all those words. Your plan sounds good. The one thing I wanted to ask you about today during this was I did not record at all where we saw the impact flashes yesterday, so I was thinking maybe I should do that. And if I mean, it's very, very, very rough, so I don't know if that's of any value or not, but if Reed and I can record a rough position in OneNote, do you want to get them off the PCDs, or you just get them when we land? What do you want to do with that?
Can you read my mind? This was exactly the first question on our list. So I'll actually just jump right in, and I think I'll answer your question. So number one question was Reed and Jeremy each reported 3 impact flashes. There were audible yells of excitement in the SIR, and we do not feel we have clarity on when the first 4 of those impact flashes occurred. And so we had follow-ups on, were the flashes brief or were they prolonged, and did you notice any color? And to directly answer Jeremy's question, yes, please do make an annotation on where you think you saw those, because right now the citizen science community is analyzing the data and trying to narrow down where you would have seen those.
Okay, Kelsey, I was just comparing notes with Reed here. We both experienced the same thing. It's a pinprick of light. I would suspect there were a lot more of them. However, you're going to really be staring at the middle of the dark and not looking at the edges of the sun glow around the moon. And it is just a momentary flash, no color, about the size of a star, and it really only lasts milliseconds. Half a second at most.
That's great feedback, Jeremy. Did want to also talk relatedly about any kind of galactic ray flashes you may have experienced. So have any of you guys experienced flashes in your eyes during the mission related to galactic rays, either like while working or sleeping, just to try to speak to the difference between those and what you saw yesterday?
Yeah, 100% difference in those and what we saw yesterday. We see, I definitely see a dozen or 2 every night when I'm going to sleep. I can talk about those if you want, the galactic flashes, galactic cosmic ray flashes. But the impacts on at least these, what we suspect were impact flashes, were absolutely different, 100% different. And Jeremy said like half a second. I would say they were a millisecond. Like the fastest a camera shutter can open and close, that is what I saw. And I would say they were just white, bluish white, and the size of, Jeremy said size of a star. I really like that analogy from space. It was just a pinprick of light. And maybe it was a priming bias, but to me there was no doubt we were seeing it. And we were all seeing it. So and we were correlating.
Great stuff, Reed. Don't need the description of the galactic ray flashes. So I guess last question for you guys on that. We definitely want that annotation. Please let us know when you have that, and we'll try to downlink it in flight. But when during the period did you see them? Because I think we heard from you like 20 minutes in that you had already seen a couple. So any timing granularity you can provide would help us find evidence from those from the ground and from LRO.
Well, I think it was just whenever we were intentionally looking for impact flashes. We were looking pretty hard. The eclipse occurred, and then we had about 5 minutes of human emotional reaction to staring at that orb floating in the vastness of space. And then right after that, we were like, oh, somebody in the cabin said, let's look for impact flashes, or I see an impact flash. And then we started looking at it, and as we were looking, we all just saw, 1 or 2 or 3. Mine were, Jeremy's annotating right now, and then I will annotate on his as well. I never saw any that would have been in the Earth glow side, so I do not suspect any that I saw would be able to be correlated from a Earth-based science team.
Great feedback. So it sounds like when you guys reported multiple impact flashes, it could have been that you guys all saw the same ones occurring. Any guidance on how many total you saw?
We didn't necessarily announce everyone out into the cabin, though. Reed and I saw 2 identical ones. He saw one before mine, and then I know I saw another one after that. So we'll try and give you the annotation and what order they came in. But just remember, this is just very rough.
That's great. Moving on, a question for Christina and any others that observed something similar. Christina suggested there may have been possible lofted dust just prior to Earthrise. Can you describe what you saw just before the Earth popped out from behind the moon? And any other crew, did you witness anything similar to what Christina is about to describe?
Hey, Kelsey. So this was during, Earthrise. I was still on Eclipse for some reason. Yes, okay. My crewmates were they didn't see it the same as I did. What I saw was when it got close, so as you know, a crescent rose, so it was kind of like 2 fangs came up, one fang and then later another fang, and then eventually the center of the smile, the crescent. And right before the center of the crescent came up right before the crescent was there was when I thought I saw something.
That's a very evocative description, Christina. Thanks. You noticed it was gray. You kind of highlighted a gray color. Did it, what was the thickness of it above the surface of the moon? And anything else you can describe about what made you think it was lofted dust?
Yeah, and to be clear, this was Earthrise, right?
Affirm Earthrise, because it's that glow from Earth that would allow that lofted dust to become highlighted against space.
Yeah, I was just making sure it wasn't right after Earth set, if that might also be a time, because the picture I'm building in my mind, I just want to make sure I'm not creating false memories. Basically, and I think this is why not everyone saw it as lofted dust, it was not tall. It was it wasn't like the corona where it came up high or anything like that. It was just a slightly different gray color right before it rose. And it was small enough to be within the fangs of the crescent. It didn't go farther than the inner part of the crescent, and it could have been an optical thing and not lofted dust, but to me it just sort of appeared, and I felt like it had a glow. I know that those different terms mean things, but I think in this case that would be the appropriate thing there, that it was potentially, in my mind, the sunlight reflecting off of the Earth and creating a little glow right before the brightest part of the crescent came over the horizon.
Exactly what we were looking for. Thank you, Christina. Similarly, on dust, we heard that Reed chose for his second crew choice target to look for suspended dust. So, Reed, did you see any glow or hints of that dust earlier that made you come back to that observation?
Negative. Just really wanted to see some, and I saw none.
Understood. Okay, for Christina and Victor, during Earth set, we heard you say that the Earth was so bright it made the moon look dark. So you all had the Earth in view during the majority of your flyby. Did you notice any time when the brightness of Earth began to change your view of the moon's brightness? And can you describe how your perception of the moon's color changed as the Earth came closer to the moon?
Yeah, absolutely. And essentially, as soon as the Earth became in the view, the easy view, where I didn't have to turn my head, when it was in what I'll call my field of view, not my field of regard, when I could just see it looking straight, the moon was already at a point where I was losing subtle albedo differences. I think it's the angle of incidence. The angle, the sun to the moon didn't change much, but we moved to the side, so we were seeing a different angle, and the color was less apparent. Orion Tall had also rotated really close to the limb, so a lot of the features that I was looking at were moving away, but I think the change in lighting was due to the angle of incidence, but then when the Earth became apparent, its brightness, it was so bright. It was so bright it looked out of place. The gray of the moon and the black of space kind of seemed to go together, but then more in the dull sense, but then the vividness and brightness, like the difference between an LED display and a painting, right? You can just do things with light that you can't do with paint colors. The Earth looked out of place, and it just continued to dim the albedo and color that was earlier apparent in the moon. I'm passing to Christina.
You saw me nodding vigorously back here. That wasn't just my fantastic listening skills. I was nodding to make sure. Oh, we're not on video. This whole time I've been putting on a show. I was nodding, now you know, because I agreed with everything he said. I'll add a couple thoughts that popped into my mind, which was, I think I made the comment that the moon turned into a sponge of light. In my mind, before the Earth came into view, the moon actually was reflecting light, and it was lit up. As soon as the Earth got close enough to be in my field of view to take them both in at the same time, exactly what Victor said, it dulled, it turned into a sponge. It's almost like it went matte, like a matte finish. And for me, so that's brightness and albedo. It also, I would say for me, got like a browner taupe color, like almost an olivey brown, kind of like the boys' pants, not like my pants, but like these pants. And whereas before, I would have said it was more like electric gray in its grayer areas. So for me, it turned more brown, but a very matte brown. I'm going to stop there. There's one more comment I'll make about when it was very close, just in case it's interesting.
Absolutely, we take that observation.
The only other thing I wanted to add to that is not scientific on lunar observations, but I think that, I know myself in particular, but probably we all underestimated the amount of impact of sunlight and earth glow on cabin windows, on glare on the window structure, window frame, on the heat shield tiles coming across the cabin. That was a pretty large impact, Kelsey.
That stuck up to us here on the ground as well, Reed, and we were hearing the struggles that all those different expected illumination sources provide, but unexpected in the impact that they had. Speaking of things that had an impact on observations, Victor, we heard during your sit rep when you were in the docking window that having that orange Kapton tape in your field of view affected your color observations. That was fascinating and has a lot of impact for future Artemis missions and hardware and impacts on color. So any other comment you want to make on how your ability to perceive color on the surface was influenced or limited by other objects of color in your view? We're interested here in color rather than brightness.
Absolutely, but all the comments I made about the Earth earlier apply to this one as well. This is the thing I wanted to make sure to add, so I'm glad you asked, is that the human eye adjusting is another thing that had huge impact. Some of the colors and their patterns did not appear in the moon. The Aristarchus Plateau, you know, the browns, the streaks that we saw there, until you stared, kind of like the impact flash. You really have to be staring. And it wasn't because of intention. It was because my eyes were adjusting. And so as soon as I would look inside the cabin, the vehicle, if those bright LEDs that were in the vehicle, or if the sun was reflecting off of a corner of the windowsill, or the bright Earth in the field of view, those things would change my eye, and I'd have to wait for them to adjust again. And I want to add, while Victor's talking about that, on the Kapton tape color, let me see if I can nod for my crewmates, but when we're looking at Earth, just a normal Earth lit up by the sun, I'm used to seeing these deep blue pictures of like Earth Day photos, Apollo 8 photos, but when we look out, the cloud cover is so bright, it is almost blindingly bright, and you really cannot make out significant detail in the Earth when we're at long distance on a sunlit Earth. So it was very interesting to me that the Earth is so bright from the clouds that it is actually hard to look at.
Hey, since we're going discussion style, like you mentioned, I'll add a couple comments on color. I didn't notice color changing my view, except maybe, like Victor said, it was I didn't realize it when I looked down at the PCD and back, because I do think there was a time scale there where you saw things a little differently if you just stared for a long time. And sometimes even staring out into the blackness to kind of reset and come back. So I think that is a note. We were very much reliant on PCDs for instruction, but that did cause our eyes to constantly refresh on those colors. I didn't notice necessarily a color difference, but just like a quality of observation, maybe like he was saying, like the details or the contrast. So it might have even been a night vision thing. Yeah, that's all I'll say on that. I did want to mention that when we were getting the really, really high amount of light into the windows, even the shrouded windows from the sun, the reflection on things behind the observer that are in the cabin was really strong on the window. So there's some high albedo things behind our heads, like there's a white bar, the abort sticker on the RHC, some other metal things, like we have some white bungees. I was trying to observe the dark side of the moon during the Earth set while the Earth was behind it, and I ended up asking Reed to give me some black T-shirts, and we covered all of that stuff so that the reflection was just less in the glass, and it worked so well. It basically made observing for impact flashes possible, whereas it wouldn't have been otherwise. So that's a good tip, and I would even recommend, like maybe as part of your stuff, if you ask this in the future, like a black room, a dark room cloth or something to lay behind the observers. Finally, back on the question of moon color change during Earth set, the other thing that happened, which was kind of, I think, just more in the category of like a mirage or something, even though I recognize there's no atmosphere around the moon that would cause the same things as mirages on Earth. There was definitely an effect, like when the Earth actually set, of like when it first touched the moon, it was like your eyes didn't know what to do at that boundary, and it kind of just created a lot of light in that spot. Once it got below that tangent first touch, then it got more normal, and I was able to just see the Earth and see the Moon and see their contact. That's all for me. Anybody else on this question?
Thank you, Christina. And as I think I saw you notice, we did just get video a couple minutes ago, so it's nice to see you as we're talking to you. Next question is for all of you. Ohm crater was observed by all four of you, and we're interested in whether your different viewing angles resulted in how you observed Ohm. Jeremy and Reed saw it first. Were you able to see the ejecta rays, the central peak? And then Christina and Victor, you were next, and you observed Ohm later in the past. Could you resolve similar or different features than what you're about to hear from Jeremy and Reed?
The ejecta blanket for Ohm, I mean, it definitely changed as we went around the Moon, but it did not change that much. It was always there. It was always fairly apparent. What is more apparent than the ejecta is the brownish gray, darker area that makes the 12 o'clock to 3 o'clock cut of the pie shape. Like that was always very apparent, and the ejecta rays just made that contrast much more apparent. But overall, Ohm did not change drastically as we went around the Moon, unlike Orion, which drastically changed as we went around the Moon. And I'll keep going there. I'm kind of going to ask Reed this question, but it was later on in the orbit that I noticed the ray of Ohm, like the primary ray of Ohm that comes out of roughly the 3 o'clock position, was on the Mare. And I'm not sure if I was picking that up initially in our first observations, but definitely in the latter. Did you notice that at all? No, the near side Mare, yeah. Yeah, Reed says he was noticing that the whole time. That might have been more noticeable to me later on, but that would be the only delta.
Understood, Reed and Jeremy. Curious to hear Victor and Christina's thoughts after hearing you guys.
For the later observation, I was able to see into the crater wall on the east side, and the shadowing there was actually neat, so I could see layers of shadow, so that there's kind of like two faces, or maybe three. I couldn't tell because we were so far away, but I could clearly see light, then dark, then light, and so the layering within the interior crater wall on the eastern side. I was able to see the central area, and I actually thought I saw three distinct groupings of something, and I think that's in the recording, but again, I was so far away, and my eyes were quite tired from adjusting. I was wearing glasses and looking in at the PCD and then looking out of the window out above the glasses, and so my eyes were really getting to work out. And they've definitely been changing. That's the other thing about the eyes, too. My eyes shifted on this. I'm about to turn 50, and that just was very different than 5 years ago. But I did see interior structure, and I commented on the colors, but again, from the angle we were from the surface, everything just looked plain. But the interior floor seemed to be the same color as the surface outside to the west, but the wall seemed to be a different color, which kind of was the same color as the rays and I think the central lift, but I said this in my recording, and it's already becoming fuzzy, but I made some correlations between there, and I talked about looking at the Grand Canyon, where you can see different layers and know that this is the same as that, even though they're not connected. I think the interior, the floor, and the wall maybe had different color or albedo, and I don't remember which one I said in the recording.
I'll pile on with your question. We just brought up the LTP because I forgot that while I was doing this, because there was no shadows on this whatsoever, I think it was towards the end when it was just in full light and very little relief, I kept losing Ohm itself. And I actually thought that there was a crater northeast of Ohm that is at the center of those kind of starfish rays. There actually looked like there was a very simple and old crater there, and that is what I kind of actually went back and forth between that one and now what I see is true Ohm, and I wish I would have referred back to my PCD at the time. But I think the lesson learned here is without any relief, it is very difficult to sometimes make out craters, especially here where the rays are actually offset from where the crater itself is. So you're drawn into a spot, and I am so surprised right now that there's not a little crater where those rays meet, because in my mind there was, and that was
And that reminds me of something else I talked about earlier. When Reed and Jeremy were in the windows, I remember looking out and I said something to you. I think that it doesn't look like purely rays. I did see the continuous feature of that east-west line, that 3 o'clock ray all the way into the near side Mare. There's some interesting something going on there. But at first, it looked to me like just two different, like a contact of two different materials coming together, or two different age materials coming together. And when we got on the far side, the far side view, where I was looking back at it, I mean, the later view, it still looked like, I don't know, it sometimes didn't look like a ray. It just looked like different color material. And really the point of this is not to talk about the 3 o'clock ray and the 12 o'clock ray. It's to talk about the wedge. The wedge looks to me, if you remember my recording comment about continents, I kind of had the near side Mare continent, the middle from Ohm to Oriental, and then the Hertzsprung continent. Those colors in the wedge look like, and not they look the color of, but also the concrete kind of packedness of what's around Hertzsprung. Those look similar. So that's kind of also playing tricks on my eyes between rays and just different material, not just a ray laying on top of the material.
Thanks a lot, Victor and Christina. Wow, we're really looking forward to continuing to dive into this when you guys are back with us on Earth. We want to sign off now to get you guys over to your next activities. Before I do that, I'll just say when you're making those annotations about the impact flashes, any annotations you want to provide about the structures in the corona you saw during the eclipse, we would take those annotations. And that's it for me. It was so wonderful to talk to you over the last 2 days. Thank you again, and can't wait to see you all back here on Earth. Thanks again for what you did for science.
You guys did an extraordinary job of preparing us. We really appreciate you. Can't wait to talk more about this. This was too short. For the sunset recording, if you're looking for that, it's on PCD3, and the file name is recording, open bracket, 13, close bracket.
Copy all, Integrity. Science is over and out.
Integrity Houston, we're maneuvering to the lunar obs attitude, and we'll be ready to dial for the PFC as soon as we see you online.
We copy, and can you say window for science pictures? We're a little PCD limited.
Checking. Christina, window 2.
Copy. We see it coming into view. You guys look gorgeous.
Why, thank you.
This is Artemis Mission Control. You just heard Dr. Kelsey Young, Artemis Science Flight Operations Lead, speaking with the crew aboard the Integrity spacecraft, Orion. Yesterday was lunar flyby day for the astronauts aboard Orion. They had about 6 hours to observe the moon, and during that time, they took turns taking photos as well as making annotations and making audio recordings that were sent to the science team last night. Of course, if you got to watch, the astronauts were also calling down information real time of what they were seeing while orbiting the moon. The conversation you just heard from Dr. Kelsey Young with the crew was their post-lunar flyby conference. As you heard, she asked some specific questions about some of the targets that they saw, as well as the configuration of the spacecraft. As this is a test flight, everything we learn on this mission helps us prepare for future Artemis missions to the moon. So even minute details about moving through the spacecraft or how vision was changed based on placement are very important to us. Now this view inside the SIR, the Science Evaluation Room, you can see this team of scientists taking a look at one of the photos that the crew shared. And you can see the photos from the crew at images.nasa.gov or by visiting NASA's social media. That's at NASA or at NASA Artemis. During the flyby yesterday, the crew became some of the first humans to see portions of the moon that had never been seen before by human eyes. Just after the conclusion of the post-lunar flyby conference with the science team, you heard NASA astronaut Christina Cook is moving into the next portion of her day. That would be opportunistic science imaging. She's going to be taking some pictures of the Earth from outside the windows of Orion. All of the Artemis 2 members will also get a chance to speak with their families today in private family conferences. Additionally, we are targeting the RTC-1 burn this evening. We're looking at about 7:03 p.m. Central Time. The RTC-1 burn stands for Return Trajectory Correction. Our trajectory was determined when we completed the translunar injection burn. So these trajectory correction burns are fine-tuned burns that allow us to just further refine our flight path on the way home. You're looking at a live view inside the Science Evaluation Room as the team continues to analyze some of the photos that the crew sent down. Again, this is the first crew to fly by the moon in over 50 years. So some of the photos they took will be of areas that had never before been seen by human eyes. This was determined by our launch date, which was April 1st. The crew additionally became the first people to see a solar eclipse from the other side of the moon. We got some live views of that real time as well. It was pretty incredible to see the corona of the sun coming around the side of the moon. If you haven't seen some of those images yet, please do visit nasa.gov. We're now a mission elapsed time of 5 days, 21 hours, and 2 minutes into the flight of Artemis 2, the first flight of humans aboard the Orion spacecraft. Orion is now 230,896 miles away from Earth, but continuing to grow closer. 44,464 miles away from the moon and continuing to grow farther. You can track these stats at any time by visiting nasa.gov/trackartemis. Earlier today, Orion exited the sphere of influence from the moon this morning. That means the gravitational pull of the moon is now no longer pulling on the spacecraft, and that they are more pulled by the gravitational pull of the Earth. Again, we're targeting splashdown in about 3 days, 4 hours, and 14 minutes in the Pacific Ocean. Our coverage remains live 24/7, all the way until...
The moon gets small quick when you're leaving it. Wow. Moon and Earth are just about the same size. We saw the Earth for a minute. Now Christina's looking at the moon. Pretty awesome.
We copy. Thanks for the report.
As you've heard throughout the flight, the Orion capsule is often referred to as Integrity. This is a name given to the spacecraft by the Artemis 2 crew members and announced last year. The crew reports that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. And that this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. You're now looking at a live view outside the Orion spacecraft, solar array wing positioned to look at the spacecraft itself. The command module of Orion, that shiny part, is approximately 330 cubic feet habitable volume. So the interior living space for the crew is about the size of 2 minivans. And that's about 60% more cubic volume than the crew members had during the Apollo missions. As previously mentioned, this spacecraft is made from more than 300,000 components. And to be specific, 355,056 individual parts compose this vehicle. This a live view inside the Artemis mission control room, where the team continues monitoring all systems aboard the spacecraft, making sure we are set for mission success. This room is also staffed and monitored 24/7. This helps us ensure the spacecraft is safe as well as our astronauts. And just down the hall, we have the International Space Station Flight Control Room, another flight control room staffed 24/7 to maintain all systems and safety for the crew living and working aboard our orbiting laboratory. Because the crew did have such a busy day yesterday for flyby, we anticipate hearing from them a little less today as they have some downtime. Even though they are potentially in an off day, each astronaut dedicates 30 minutes every day to exercise. When in a microgravity environment, the astronauts could experience bone and muscle loss if not continuously exercising. So Orion is equipped with a flywheel, which is a small device. It's been installed directly below the side hatch. The flywheel is a simple cable-based device, and it can be used for both aerobic and resistance workouts, and we've seen some of those from inside the spacecraft. We've also been able to see some of the movement that happens outside the spacecraft when the crew is working out. So during exercise, the crew or the ground team can park the solar arrays and prevent any loads being imparted on them that might damage them. Again, we're live here in the Artemis Flight Control Room. 5 days, 21 hours, and 15 minutes into the Artemis 2 mission. This is the flight day 7. And again, this is a little bit of a quieter day now that we have had the ship-to-ship call with the International Space Station and the post-lunar flyby conference with the science team.
Integrity Houston, we're maneuvering back to bias tail to sun. Also, we're preparing to clean up your onboard burn plans, and at DPC, we forgot to ask you for AGA numbers. Could you please give us those?
Okay, Stan. AJ just came on, as you heard. Give us 5 minutes. We'll give you a reading, and we copy the other remarks. All good?
Roger.
The voice you hear communicating with the astronauts today from Artemis Mission Control is NASA astronaut Stan Love. He's the Capcom for today. The Capcom stands for Capsule Communicator, and that's the single person in the room that communicates with the crew. This keeps their communications streamlined, both from all the ground teams to and from the astronauts.
And Houston, integrity for opportunistic science imaging note.
We're listening.
Yeah, just wanted to mention that towards the end of that opportunity, I'm not sure if it was after the maneuver started or just before it started, but the sun was out the window that I was observing on, and I went to go look for the moon to take more pictures of it after kind of pulling my vision away to look at the lunar targeting package. And when I put the camera back out, I ended up pointing it directly at the sun for a second. So just a reminder that if something's gonna change to where the sun is now in the view that people are looking out at the camera, just give us a heads up.
We will do that. Thanks for that information. On another topic, your new state vector is on board.
Awesome, thanks, and I'll be ready for my PFC in a couple minutes. Do I need to tell you all which PCV I'll be on?
And Christina, no, we don't need to know which PCD you're on. We'll just dial your account.
Copy, I'll be signing in shortly. Appreciate it. Okay, got it. Thank you.
As you heard, that communication's coming from Orion and NASA astronaut Christina Cook, mission specialist. She had an opportunity to do some opportunistic science when the spacecraft's attitude was pointed to allow her to see Earth and the Moon at separate times. You also heard Christina calling about her PFC, that stands for Private Family Conference. All of the crew members are getting some time to talk with their families today. Meanwhile, NASA astronaut Victor Glover is scheduled to conduct some aerobic exercise on the flywheel. Teams here are sending commands to park the solar arrays in safe harbor. That prevents any loads being imparted on them while the crew is exercising. Coming up in about 30 minutes, we will have our daily news conference for Artemis 2, where leadership here for the mission are at Johnson Space Center, and we'll be able to discuss the latest status on Artemis 2. Again, that's coming up at 4:30 p.m. Eastern, 3:30 Central. That'll be broadcast on this stream on NASA's YouTube, but we will still have our clean feed on the separate YouTube stream. Once that status briefing is over, you can come right back to this feed or just stay right here and we will continue coverage from inside Mission Control Houston.
we are go for secondary purge line dumps.
We are go for those dumps.
Can you remind me again, Stan, when we have to stand down from them today?
Checking. And Reed, we'd like you to stand down from CCU dumps between MET 3 hours and MET 5 hours 30 minutes, except for the scheduled dump on Victor's timeline at 3:10.
Okay, we copy, Stan. I'm in the process of setting up the recorded exercise. I would appreciate a call up with a 2-minute warning to stand down from exercise.
That's on our to-do list, Victor. Don't worry.
Live here in Artemis Mission Control at Johnson Space Center in Houston, Texas. This is a visualization on your screen, and you can access this anytime on your own device by visiting nasa.gov/track-Artemis. This is called ARROW, the Artemis Real-Time Orbit website. We're about 40,000 miles farther away from the moon than we were this time yesterday during our lunar flyby. And if you have not seen some of the pictures coming down, please do check out NASA social media. They are absolutely phenomenal.
Integrity Houston, Orbit 1 team is stepping off headset for a few minutes to take our team photo. We'll be back with you shortly. Sure.
Sounds great, Stan. Enjoy that and savor that moment. Please savor that moment. What an exceptional time.
Will do, sir.
Those communications coming from Capcom and NASA astronaut Stan Love to the crew aboard Orion. The Orbit 1 team is monitoring the consoles here at Mission Control Houston, led currently by NASA Flight Director Jeff Radigan. The team's going to take a brief team photo. This is the team that has served this shift for the entire mission and has been training together for a significant amount of time now. All of these flight controllers are the ones keeping the systems and the crew safe aboard the Orion spacecraft for the Artemis 2 mission. Additionally, we have the Orbit 2 and 3 team with the same tasks, and they'll be taking their own photos. This is Artemis Mission Control continuing to monitor the flight of Orion. We are now 5 days, 21 hours, and 36 minutes into the Artemis 2 mission, the first flight of humans aboard Orion. The Orbit 1 team is currently on console here in Artemis Mission Control and just took a group photo. We are on flight day 7 of this 10-day mission, with Orion targeted to splash down about 3 days, 3 hours, and 40 minutes from now. This room is full of team members who make this mission possible. That includes Prop, the propulsion officer, CDH, command and data handling, INCO, our integrated communications officer, MPO, the mechanical and power officer, and so many more.
Houston Integrity, are you ready for AGA readings?
Yes, Jeremy, we're ready to take those AGA readings.
And Houston, there's no rush if you're still taking the photo. Just going to give you AGA readings whenever you want them.
Jeremy, go ahead with those AGA readings.
.8 for for O2, and CO2 is 1.5.
Copy numbers. Do you have temperature and pressure?
.4 for pressure and 77.3 for temperature.
Copy all. Thank you, sir.
And you just heard Canadian Space Agency astronaut Jeremy Hansen calling down some AGA readings. The AGA is the Anomaly Gas Analyzer, and this is powered on before exercise. It takes about 5 minutes before they can give readings, and they want those readings once they start exercise and afterward. This is the first flight of humans aboard the spacecraft, and therefore the first flight of our ECLIS system, the Environmental Control and Life Support System. So these readings help the team on the ground understand what gases are in the cabin, as well as temperature. You just heard it's about 77 degrees Fahrenheit aboard Orion.
Integrity Houston for burn conference and targeting.
Go ahead, Stan.
Hey, Jeremy, our GNC maneuvers are conflicting with our preliminary targeting activity, so we may have to do prelim a little later, or we may skip it entirely and pick up at intermediate. We'll keep you posted on how it's going.
Okay, copy that. And then when, just keep me up on when the latest trajectory information is on board for targeting. Do we have the latest burn plan on board?
Jeremy, we do not have the latest on board yet. That's one of the things that we're trying to catch up with. So the burn conference scheduled before preliminary targeting is definitely canceled. Again, we'll call you when we have updates.
Okay, understood, Sam. No problem. We're pretty flexible.
And Jeremy, we're expecting approximately 30 minutes to get the new burn plan on board.
Okay, understood, Sam.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. The voice you hear on the ground is Capcom and NASA astronaut Stan Love speaking with the crew aboard Orion, specifically Canadian Space Agency astronaut Jeremy Hansen. We are targeting the RTC-1 burn today. That's Return Trajectory Correction 1. That is targeted for about 7:03 p.m. Central Time. This is a small burn using the reaction control system thrusters on the service module of the Orion spacecraft. This helps us fine-tune our path back home. Stan Love was letting the crew know that we are canceling their first preliminary burn targeting conference. They have another one of these in a couple of hours when they will have the final burn plans uplinked and the final targeting complete. It's now been 5 days, 21 hours, and 51 minutes since Orion launched atop the Space Launch System in Kennedy Space Center in Florida. The crew aboard Orion is getting into the first few hours of their day. They woke up approximately 10:35 a.m. Central Time today to the song Tokyo Driftin' by Glass Animals and Denzel Curry. There are a few more open blocks of time on the crew's schedule today, as they had an extremely busy day yesterday with lunar flyby. Right now, pilot Victor Glover is exercising. And Christina Cook is enjoying her private family conference. You heard her call down just prior to that she was ready for her PFC, and that's what that stands for. All of the crew members are getting a chance to talk to their families today. Thanks for joining us for our live coverage of the Artemis II mission. We are expecting to have a news conference today with mission leadership here at Johnson Space Center in Houston, Texas. We are expecting that news conference to start around 3:45, and I assume you're watching this on NASA's YouTube stream, and if so, if you're interested in watching the press conference, you don't need to change the channel or change your stream. We will be airing that right here. We also have a secondary stream with raw audio and video, and you can find that also on NASA's YouTube. Here's a video from the outside of Orion, and as we mentioned, pilot Victor Glover is exercising. We do see the spacecraft move a little bit when the crew is exercising, and so the teams here park the solar arrays into a safe harbor position. That means any motion that they experience due to the exercise doesn't damage the solar arrays. If you're just tuning in and you are looking for the news conference that was originally slated for 3:30 p.m. Central Time, we are now expecting that to begin 3:45 p.m. Central Time. That will be live here on this YouTube stream. This is Mission Control Houston, specifically the Artemis Flight Control Room here at Johnson Space Center in Houston, Texas. This is a live view from a camera mounted on one of Orion's solar array wings. Interestingly enough, each of these solar arrays provides enough electricity to power 2 3-bedroom homes. This camera looking back on the European service module as Victor Glover, pilot of the Artemis II mission, conducts his exercise for today. That's why you are seeing some movement on your screen. We are mission elapsed time 5 days, 22 hours, and 2 minutes into the flight of Artemis II, the first flight of humans aboard the Orion spacecraft. And if you are looking for the press conference that was slated to start at 3:30 p.m. Central, we are now expecting that to start closer to 3:45. You're in the right place. You're watching live coverage of the Artemis 2 mission, the first flight of humans aboard Orion. This is a view coming from outside the Orion spacecraft on one of the solar array wings, pointed back at the spacecraft. And as we mentioned, you see some movement because NASA astronaut Victor Glover is in his exercise period for the day. The crew is having a little bit of a quieter day after a very busy schedule yesterday, photographing and recording observations about the lunar surface as the spacecraft approached just about 4,067 miles away. Our distance to Earth continues to shrink now as we are preparing for splashdown on April 10th. We're standing by for the start of our daily press conference here at Johnson Space Center in Houston, Texas, and expect that to begin momentarily. So if you are watching this channel and looking for more spacecraft views, you can switch to our other live stream. Otherwise, you can stay.
The Artemis 2 mission is a test mission of the Orion space capsule.
Artemis 2 will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together. That's what's up.
To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Good afternoon, and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Bethany Stevens, and we are here today to provide a status update on the historic first crewed test flight of the Orion spacecraft post-lunar flyby. On our panel today, we have NASA Administrator Jared Isaacman, Dr. Lori Glaze, head of Artemis, Rick Hinfling, Artemis 2 Flight Director, Kelsey Young, Artemis 2 Lunar Science Lead. We'll start with opening remarks from each of the briefers before opening it for questions in the room and on the phone bridge. If you're on the phone, press *1 to submit your question. When called upon, please state your name, affiliation, and to whom you'd like to direct your question. With that, I will hand the floor to Administrator Isaacman for his remarks.
Thanks, Bethany. It's been an exciting Artemis II mission so far, and a very eventful 24 hours as the crew surpassed the Apollo 13 distance record, 252,756 miles from Earth. They relayed observations from the lunar surface. They've captured some incredible imagery. They performed a ship-to-ship call with their colleagues on the International Space Station. They performed additional manual piloting of the Orion spacecraft. They've been working at a reduced cabin pressure of 10.5 psi in support of future integrated lander operations, and they did take a call from the President of the United States, Donald J. Trump. We had millions of viewers on that that tuned in for that historic broadcast, and it concluded with the President promptly inviting the astronauts to visit the Oval Office. Now, Integrity left the lunar sphere of influence earlier this morning, so they're now approximately 229,000 miles from Earth, and they will splash down Friday evening at approximately 8:07 p.m. Eastern Time, and the recovery weather is so far looking favorable. Now you can see some of the spectacular images the crew have captured here on our screens. There we go. Now this is the first time humans have documented some parts of the far side of the moon. Now, these images will be publicly available on NASA's website, our digital platforms, and the White House actually released the now iconic EarthSat photo from earlier today. Now, these are the first of many incredible images of the moon, and we'll continue to release them as they become available. My understanding from just a few minutes ago is that they captured over 175 gigabytes of imagery from the lunar pass alone just yesterday, and the images that you are seeing right now have been transmitted back to Earth predominantly through optical communication, which is pretty cool stuff. Now, before I turn the call over to Dr. Lori Glaze, I wanted to share some of the other things that we are doing at NASA while the Artemis II crew are underway on this historic mission. So the crew on the just yesterday, I'll believe the favorable. Now you can see some of the spectacular images the crew have captured here on our screen. '59 almost daily while the Artemis II mission has been underway. So we work to rebuild our X-plane portfolio. The first senior level Artemis III mission design discussion today. Teams are working with vendors on moon-based RFIs and RFPs, and we are advancing the Skyfall scientific payload for the first interplanetary nuclear-powered spacecraft, SR-1 Freedom. I think the most important point we're trying to make here is we can launch history-making missions like Artemis II, start making meaningful progress towards Artemis III, and do all the other important programs the world's been waiting for from NASA. And with that, I'll turn it over to Dr. Glaze.
Thank you, Jared. I just have to say, wow, when I look at all of those images that were scrolling by. I hope all of you are as inspired as I am. I know as they continue to be downloaded, they're just absolutely stunning, and we really hope that they are inspiring truly everyone in the world. As the crew surpassed their record for the farthest distance, as Jared just mentioned, when they traveled on the far side of the moon, they offered some compelling words, and I love this. They said they challenged this generation and the next to make sure that this record is not long-lived, and I love that because we have big plans to go not just back to the moon on a regular basis, but beyond. And then, of course, while it's been really exciting here the last couple of days, as we've been watching all of the activity in Orion, we still have to ensure that Reed, Victor, Christina, and Jeremy return home safely on Friday evening. So we're pretty focused on that now, making sure that they get home safely. I will just say a couple of things about yesterday's operations. Really provided a great opportunity to test how our flight operations teams and our science teams are working together in real time with the crews at the moon. And in fact, from my perspective, one of my favorite things about watching all of the amazing data that was flowing down yesterday is thinking about how so much of NASA is working together in order to enable all of what you're seeing.
Victor, this is your 2-minute warning. Please stop exercise within 2 minutes for the off-nap maneuver.
All right, better stop exercising. But as I was saying, what's really great to see everybody working together. So I think about our exploration programs that are supporting our transportation systems like Orion, working with our flight operations and our flight directors, all of the ground teams that are supporting, including the science team supported by the Science Mission Directorate, thinking about our crew that are actually performing the work, and then the payloads that have been provided that they're using. So everything that you're looking at isn't just, it's not just the pretty pictures, it's a huge chunk of NASA working together to enable that. All of this information that we're gathering is really going to help refine how we plan our future missions to the lunar surface. I'll just say that our flight operations team continues to fly Orion and put it through its paces as the crew and the spacecraft make their way home. And the mission isn't over yet. We do continue to learn from how our spacecraft and our crew are operating together in space. We continue with several of the science activities that are focused on the crew health and life in space. So still a lot of things going on, and with that I'm going to pass it over to Rick so he can share some of the operational details.
Thank you, Lori. The administrator touched on a few of the operations that the crew's been up to recently, but I'll fill in a few of the other details of interest. Since we last met Sunday evening, the crew performed the first orbital trajectory correction maneuver, outbound trajectory correction maneuver number 3. It was 10.4 feet per second. The burn duration was 19 seconds, and we used our auxiliary thrusters on the service module. Obviously, yesterday was the big day with flyby, and I'll save all those details for Kelsey, but you know, we had some really poignant remarks from the crew, and I can assure you there wasn't a dry eye in mission control when the naming of the 2 craters was announced by Jeremy. As part of the lunar flyby, the crew made their pass closest to the moon, flying at 3,138 miles per hour relative to the surface of the moon. And now they're on their way making their march back home to Earth. We bid a temporary goodbye to the moon earlier today at 1:23 p.m. Eastern Time. That's the milestone where we exited the lunar sphere of influence and we're back under the control of Earth's gravity. As for today's operations, we had a couple of public affairs events. The crew is going to have, each of them will have a conference with their family members. We'll have some routine medical checks. And then in the evening, we're going to perform the first return trajectory correction maneuver. It will be 1.3 feet per second. It'll last about 15 seconds, and we're going to use the service module reaction control system thrusters to do that burn. We expect that burn to occur about 9 p.m. Eastern Time. Finally, I'll conclude my remarks with acknowledging that the USS John P. Murtha has left port and has started steaming out to the midway point for the recovery of Integrity and her crew later on Friday. That's all for today's operations update, so I'll hand it over to Kelsey.
Thanks. Spirits are very high. We did what we set out to do. The lunar science team and the crew prepared extensively, as we talked about a couple days ago, for flyby, and I hope you all saw that yesterday during execution. We confirmed, as Lori mentioned, that we can, achieve science through orbital observations and through integrating science into flight operations. And as Rick just said, we left temporarily, and we're looking forward to integrating all these lessons learned in future missions. I can't conclude opening remarks without diving into science detail, so forgive me just a couple deep dives. Impact flashes, over a 30-minute observation period, and this was largely during that time of the eclipse, crew observed several impact flashes. We did have citizen scientists here on Earth also looking for flashes, and I know that the Lunar Reconnaissance Orbiter team is hard at work trying to identify evidence of those impact flashes that the crew observed. I did have a chance to have the post-flyby crew conference with the crew this morning, and we asked a lot of follow-ups on those impact flashes. Impact flashes are caused by micrometeorite impacts hitting the moon, and they really help tell us about the dynamic lunar environment, which is, of course, also important when we think about future missions. I don't know if I expected to have the crew see any on this mission, so you probably saw the surprise and shock on my face. And though I was not in the science evaluation room, I heard that there were audible screams of delight. So, very excited science community. You've heard me talk a lot about the importance that human explorers bring to scientific exploration, especially around observations of color. And so I'm sure all of you, like I was eagerly awaiting if they saw any other colors other than black, white, and shades of gray. You heard that they did indeed. Right away, they started describing the green around Aristarchus Plateau and different brown hues. And these colors really help tell us nuances about the chemistry of lunar material, especially the greens around Aristarchus. That was exciting. That's something that we can all see from here on Earth. And so I encourage you all to go out and look at the moon tonight and look for Aristarchus and imagine those green hues that the crew members saw. You heard a lot of discussion, especially from our pilot, Victor Glover, about the Terminator, which really, to our mind, highlighted the benefits and also the challenges for future surface operations. The lighting conditions along the Terminator that the crew experienced yesterday do mimic, in many ways, the lighting conditions of the South Polar region. The low sun angles, the dramatic lighting causing, the extreme shadowing, and illumination also accentuating topography. This is really important for our agency's future moon-based plans and understanding how crew member observations can contribute to future mission planning. And finally, the Artemis II crew, in a very poignant moment, offered proposed names for two unnamed craters in the moon's eastern hemisphere: Crater Integrity for their vehicle and Crater Carol for Commander Wiseman's late wife. I think we have a picture. Yeah, thank you. Upon return, the crew does plan to submit these to the International Astronomical Union as consideration for official names. There was, as Rick said, not a dry eye in the house. Really poignant moment, and that we were really glad to observe them describing. And with that, I think we can take questions.
Yep, we will open the floor and take questions, and my colleague Will over here will pass along the mic. We can start with you, Jackie.
Thanks so much. Jackie Waddles with CNN. I don't think there was a dry eye on Earth when Carroll Crater was named. I was just curious, was Reed aware that that was going to be something that the crew was going to do? I was just curious if there was any pre-planned discussions and they were just kind of looking for the crater, or kind of how that came about. And then really quickly, I also wanted to just check on a toilet status update. We heard this morning that I thought I heard some chatter around it being considered, a reentry issue now. Like, is the toilet out of commission until they get back, or where does that stand? Thanks.
I'll take the second part.
Okay. Yes, I know the crew put a lot of, obviously, thought and pre-planning into what you heard yesterday. It is my understanding that he was aware prior to yesterday.
And the toilet remains operational. The challenge that we're working through is evacuating the wastewater tank. The vent is a lot less than we were expecting, and so we're having to fall back to some other alternate means other than the toilet. But what you overheard on the space ground, or on the Orion to Earth channel this morning, was us deferring some maintenance on the toilet. Typically, when you have 4 crew members using it throughout the day, nominally, you have to do a maintenance activity once a day. And with a lower use rate, since we're not able to vent the wastewater products, we don't need to do the maintenance as often. And so that's what that exchange was about.
Thanks. Irene Klotz with Aviation Week. I'm over here. Jared, that's a pretty impressive and full portfolio of missions you outlined that NASA's involved in now. And without getting you in trouble with your boss, are you going to be able to defend an $18.8 billion budget, $5.6 billion for 27, or are you prepared to kind of work with Congress to see if the administration will support more Thank you.
I will say we'd like to keep the focus on what we were speaking about today and then move on to other questions like that at a later date and keep the focus on the mission. Thank you.
Mark Strassman, CBS. I feel as though I talked to about 10 people off campus today, and they all wanted to ask me about those remarkable images. And so they asked me, so I'm going to ask you. Have you seen anything in those images that surprised you? And what about those images touched you?
Take that, Kelsey?
Sure. Oh my gosh. When I woke up this morning, I've spent most of my morning just flipping through, the thousands of images that have started to come down. And there is something in every image that surprises me, right? I mean, you might think that after looking at hundreds of images taken of the lunar surface, I would get sick of it. I have not, nor do I anticipate getting sick of it. It's just their experience and the amount of time and the rate at which they were moving. Every vantage point is different. You heard them audibly describe yesterday, wow, I'm looking at the same feature as I was 10 minutes ago and it looks different, right? And the images reflect that. And so, when I see these images, I connect to each one in a different way, especially in light of what we heard from the crew yesterday. I think as a geologist by training, I love looking at the pictures of the lunar surface, but I think certainly, emotionally, a lot of us have connected with the images of Earth, with the images from during the eclipse, with the images from the vehicle cameras taking pictures of the moon during the eclipse period. And while they are inspirational and I think allow all of us to, really feel a little bit of what they were feeling, there's also a lot of science hidden, inside of those images. And I can tell you that right now, as we speak, there is a science evaluation room full of several dozen scientists who are already getting going on those images. Just as one example, there was a healthy scientific debate this morning about some of those images taken during the eclipse period and what we can see of the solar corona and what we can see of zodiacal light. So the conversations and the science lessons learned are just beginning.
Hi, TJ Mascara with the Epoch Times. Thanks so much for taking the time. For Jared, as we saw with Artemis 2 going around the moon and having that very characteristic blackout of when they go around the moon. How much longer are missions to the moon going to have that as we develop a moon base? And where do, say, communication satellites in lunar orbit land on the priority list?
Yeah, I'd say, people have asked quite a bit about, it was elevated blood pressure when we were without comms with Orion on the far side of the moon. We have comm issues in LEO relatively, routinely. Certainly our operators train for it, our astronauts do as well. But in terms of the bigger picture, can we do better? For sure, right? We've talked about, prioritizing observation and comm relay satellites for lunar operations so we can bring the world along with us as we build out a moon base. And I think I was in a meeting not that long ago where we described it as if not the platinum age for commercial communication capabilities, certainly the golden age. We're very close. So we have a number of providers that are all investing heavily in these kind of capabilities that we can take advantage of in LEO, cislunar space, and I have no doubt in lunar orbit in the years ahead.
Hi, Kay for Interstellar Gateway. Thanks for doing these. This is really cool. Jared, question for you. Can you speak on the responsibility of what being the administrator during such a pivotal moment means? And secondly, I'm speaking on behalf of musicians around the world and bands. I have a band called Chasing Satellites, and will there be potentially an opportunity to submit music for a future Artemis mission for the wake-up calls? That was really cool to be a part of and to watch as a musician.
Certainly. So I think I've described before that I thought that certainly felt a lot more pressure, being on the outside and responsible for a human spaceflight mission than being in the vehicle itself, especially a mission such as Artemis 2, which kicks off so many other exciting ones to follow as, we return to the moon and build that enduring presence to learn so that we can undertake even grander missions, as Dr. Glaze referenced, beyond the moon in the future. So I think it is a great responsibility, but you derive confidence from all the expertise that exists within NASA, the workforce, our commercial, our international partners that come together for a moment like this, all the testing that goes into it, and the fact that we have this playbook before and we're running it. Now, in terms of contributions for music and future wake-up music for subsequent missions, I hope we're running so many missions to and from the moon in the future that we're going to have to cast a very wide net for creative content. So.
Thank you. For Administrator Isaacman, Tom Costello with NBC News. I'm just wondering, how are you feeling now? I realize we don't have the crew home yet, but you've had a very successful trip around the far side. How are you feeling about this setting the stage, testing out the vehicle for a lunar landing as soon as 2028?
Yeah, well, I mean, I'd say for this mission, we're certainly off to a good start. I mean, clean launch, and the vehicle has been doing well. I've made commentary early on that I like that we're talking about, water access valves and cabin temperature and even plumbing issues, for that matter, for all the things that we could have been potentially talking about prior to the mission underway. But I'll breathe easier when we get through reentry and everybody's under chutes and in the water. In terms of getting ready for the subsequent missions, it's kind of why I picked some of the words that I did at the beginning of this press event, is that a lot of people's rightful attention right now is on the crew of Artemis 2, especially here at JSC and Mission Control, especially the recovery forces that are now making their way out to bring this crew back to their family. And for everybody else, we've got the other things to get done, including thinking about Artemis 3. It's why I was very happy that the crawler is making its way out to 39B right now. We've got a timeline to get it back in the VAB, ideally in a week. That would cut down on the turnaround, I think, by 3 months compared to Artemis 2. So we can undertake, again, world-changing missions like Artemis 2 right now and get ready for the next ones at the same time.
Hi, Josh Dinner, Space.com. Has this mission revealed anything about life aboard Orion, crew workload, flights in deep space, or maybe something unexpected that will shape how NASA and Artemis crews approach preparing for future missions?
You want to take that, flight ops?
Yeah, that's a really interesting question. We've learned a tremendous amount as part of a lot of the flight test subjective activities we've been doing. I think we have a couple of problems that we still need to work out, but Orion has shown itself to be a very capable capsule for beyond Earth orbit space travel. And I think the things like, as the administrator talked about, the things that we're going to have to improve upon for Artemis 3 are relatively small and incremental in nature, as opposed to wholesale redesigns of spacecraft subsystems. So overall, I'm extremely pleased with the performance of the spacecraft and how it's served as a campsite for our 4 crew members.
We'll go from Marcia to Eric and then do a couple on the phone bridge.
I'm Marcia Dunn, Associated Press for Dr. Young. It's hard for me to know how quickly these pictures are coming down. How many would you estimate that have come down so far of the moon? And these luminous flashes on the surface, was that an actual meteor shower, do you think, or is it just your usual business of falling debris?
Yeah, so the team, the FOD team, is working really hard to bring down the images as fast as they can. Of course, we also have other vehicle data that needs to come down as well, but the team is working really hard to try to get those images down and of course, get them out to you guys as well. As of the time I left Console, roughly an hour ago, there was just over 50 gigabytes of data from yesterday that had come down. Of course, every image does not exactly have the moon in it, but it is taken from within the lunar observation period. So we're working really hard to get those down, as well as the audio files that the crew were taking. That's a really rich scientific data set because it captures the nuance of what the crew were seeing. You know, we heard a few of those per hour in those science situational reports you were hearing yesterday, but there are multiple hours of recordings of, you know, meaty science observations, about 2/3 of which we've been able to get down so far, and our team has already been looking at that, you know, those couple hours of transcripts and audio files. As for the impact flashes, yeah, absolutely. I mean, we think they saw at least 4 and possibly up to 6 impact flashes. Again, I talked to them about that just this morning in the crew conference with them. I think, you know, you know, it's very early to tell, right? This happened less than 24 hours ago. Our teams are looking at it now, and spacecraft like the Lunar Reconnaissance Orbiter will be really helpful to try to help us narrow in on that. But the lunar environment is a dynamic place, and we have a lot to learn about it. You know, LRO has returned a lot of information about the lunar environment, but observations like this are a critical part of our understanding, which will pay dividends for future surface exploration.
Eric.
Eric Berger, Ars Technica. There's a question maybe for Jared. So why haven't we been back to the moon in 53 minutes? I'm just kidding. So you brought up the Artemis 3 mission design. Can you bring up sort of, or talk about the 2 or 3 hardest problems that you're tackling? Sort of, you talked about the mission design meeting today, but sort of the 2 or 3 hardest problems you're tackling right now to make sure that launches next year.
Yeah. So I don't want to get too far out in front of a mission that's underway right now. I would just say that there are a lot of things based on the information we have available today, from feedback from our vendors, that we know are achievable. And I think one of the questions probably will just be what the initial orbit will be for Artemis 3. Is it going to be LEO or HEO? And I think that we're all going to have some sense of which one, and there's pros and cons for each of them for sure. We're all going to be able to have some sense about which path we'll likely go down based on launch cadence of our 2 HLS providers, both of which have launches coming up, I would say, in the next month or less right now. So a big key to our strategy, not just to return to the moon, but to stay and to build a base, is going to be rapid reusability of heavy lift launch vehicles. So the more they get experience doing that, the more options that are available for us for Artemis 3. But I'd say right now, we certainly have a good plan for that mission. Will help us buy down a lot of risk in advance of a landing for Artemis 4 in 28.
Jeff Faust with Space News.
Hi, Jeff Faust with Space News. Question for Dr. Young. Now that you are going to get all of these images and verbal descriptions and annotations, what's the plan for the science team in the days and weeks ahead to go through all of that data and see how they address the 10 science objectives that you laid out for this mission? Thank you.
Oh my goodness, what a good question. We have a lot of data to get through. Like I said, it has already started. We had teams working overnight, you know, after the crew went to sleep, as soon as we started getting data down. You know, I will reiterate that we will be getting all mission data relevant to lunar science archived and made publicly available within 6 months post splashdown. So these are all of the images of the moon, these audio files, and even the annotations. But in the meantime, over those next 6 months, we're also going to be preparing 2 reports that we also owe to be publicly released within 6 months post-mission. One is a science operations report that describes, you know, how our team was structured to integrate with flight operations to accomplish our objectives. But relevant to your question, the second one is a post-mission preliminary lunar science report. And so we are going to be going objective by objective with those 10 lunar science objectives you referenced, looking across this entire, you know, really rich, robust, but very large data set, and really trying to understand what data we got relevant to each objective, but set up the community for success so that they can access those data and help us answer these fundamental driving science questions. You know, the lunar science team for this mission, it was our charter to develop the objectives and to maximize the science value out of this mission. We'll be doing an initial assessment over 6 months, and then we're really eager to see what the community is able to do with these data.
We'll move to Ken Chang with the New York Times.
Thank you. So I have some questions about the optical communications. How was the performance like? How many gigabytes was sent? What was the data rate? How does that compare with what was expected? And how does it compare with the usual way of sending data back? And it seems like it's been almost operational already and not just a test. Thank you.
Yeah, I think the question was relative to some of the data rates for the optical communication system. I'll just give you a stat from overnight that we heard from Console. We got 20 gigabytes down in a little more than 45 minutes. That's orders of magnitude more than we get via our S-band telemetry system. So optical comm has been working really well, and hopefully we can take what we learned on Artemis 2 and expand its operational capability and its implementation for future missions.
And now we will move to Lauren Grush with Bloomberg.
Out to me yesterday was just the vivid descriptions that the crew used for what they were seeing and how they remained in kind of constant contact and talkative throughout the flyby. I'm wondering if it's possible to say how that might have compared to the Apollo crew observations and how that robustness impacted the science and the data that was collected.
Absolutely. I mean, probably a lot of people watching have spent a lot of time looking back at Apollo and maybe watching Apollo in real time online and reliving what the Apollo crews, not just on the surface, but in orbit experienced. You have, I'm sure, heard the Apollo descriptions of the lunar surface from orbit, and they were also really impactful. They trained heavily in geology and orbital observations, just like the Artemis 2 crew did. I will say, listening to the level of scientific discourse that the crew was having yesterday was incredibly inspiring. I mean, a testament to how much they prepared before this mission. You know, I heard a couple times Christina and Victor especially saying, when we took the time to actually talk to each other about a specific target that we were both seeing, we elevated each other. We elevated what we were able to pull out of that target. You know, more brains on a scientific target are better than one, and we heard from them directly multiple times that they were helping each other to advance their scientific understanding of what they were looking at. We actually also heard them say, hey, we have a hypothesis. Can you guys provide guidance on that hypothesis, like right now in the middle of our flyby? So the science team was saying, you know, was cross-checking what they were seeing, was reading up geologic ages of major lunar impact features, and it was informing the observations they were making during the flyby. I mean, this is absolutely everything we hoped for by integrating science into flight operations, you know, because, again, science enables exploration and exploration enables science. And the fact that, you know, they're giving observations and, you know, I was able to immediately follow up on those observations with, you know, just the quick questions that can enhance science return, it meant that they were evaluating and buying down multiple working hypotheses in real time during their flyby. And just imagining the future when we have crew on the surface for short duration missions and ultimately the moon base, the amount of science we are able to gain when, you know, science is woven into this operational fabric is incredibly impactful. And we saw that, you know, for 7 straight hours yesterday.
Now we'll move to Micah Maidenberg with the Wall Street Journal.
Hey, good afternoon. For Rick, what is the approximate time on Friday when the crew module separates from the service module, if you have that on hand? You know, the administrator mentioned splashdown is expected for around 8:07 Eastern. And then any color on kind of reentry prep work ahead for the crew and mission control between now and Friday. Thanks.
Sure. I'll start with some of the times. The crew module and service module separation is going to occur about 20 minutes before entry interface. So that separation will be at 7:33 p.m. Eastern Time. We expect entry interface about 7:53 p.m. Eastern Time. with a splashdown around 8:06 p.m. Eastern Time on Friday. As for the preparations that the ground and the astronauts are doing today to prepare for entry, or today and future days, a lot of it is all of the science equipment and cameras and tablets and reference material that got unstowed in support of the flyby. Well, we have to put that all away. We have to pack up our suitcases and get ready to come home. And that takes time, and so we are laying out a plan to make sure that the crew gets everything packed away in time to get their suits on and get in their seats to perform that final trajectory correction maneuver on splashdown day and come home.
We'll move back in the room to Joey and then on to Will.
Thanks. Joey Roulette with Reuters. I just had another quick toilet question. Do you have any idea as to why the venting is not happening as fast as you hope it is, and what other hardware on the spacecraft might that implicate, or what other problems might that cause?
Yeah, so the engineering team is going to go through a full fault tree to identify all of the potential causes of the blockage. Initially, you may have recalled that we thought it might be icing up at the nozzle at the outer mold line of the spacecraft. We have pretty high confidence that it's not an icing condition. We've put the spacecraft in a sun-focused attitude to bake off any ice. We've activated heaters along the lines internal to the spacecraft, and we still see a blockage. And so the latest theory is related to some of the chemistry that goes into ensuring that the wastewater doesn't develop any biofilms. And there may be something going on with a chemical reaction where there's some debris that's generated as part of that reaction, and it's getting clogged in a filter. But again, we don't have root cause, and once we get the spacecraft back into the processing facility in Florida, we'll be able to get access to all the components and do a real detailed fault tree to identify the root cause.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you all for taking the time. Going back to Dr. Young's point about the intersection of science and exploration, to both Dr. Young and to Dr. Glaze, given the number of believed to be impact flashes that the crew observed during just a relatively brief amount of time, I wonder how these observations and the ones made previously by LRO will factor into creating the conditions for a moon base that can allow the astronauts to stay safe, given the probability that they may experience a micrometeoroid impact at that site. Thank you.
Well, I do think that the data that we're collecting with these observations, and as you noted, the LRO data that we're continuously collecting, we have been for quite a while, all of that is being fed into our plans and making sure that we understand what all of the variety of risks are. There's many that we're looking at, and of course micrometeorites being one, as we start to establish infrastructure on the surface and understanding those rates. These kind of data really help inform us as far as what we can anticipate. And of course, the different parts of the moon, down at the South Pole, maybe a little slightly different rates than we would see higher up at higher latitudes. So we need to compile all of those data and understand where, what those impacts might be.
Hi, I'm Nick Notori with ABC 13. A question about the scientific stuff that you found yesterday. I know the question was asked about what was inspirational. I talked to Joel Kearns yesterday, and he had told me, I'm just looking at his quote, as a scientist, I can tell you what's most inspirational is when you're pouring through something you're working on and you realize you're seeing something that nobody else has ever seen before. I know you talked about the impact flashes, but is there anything else that no one else has seen before that you guys have already saw? And then also explain to us on Earth that maybe this is high level over our heads, how what was photographed or taken yesterday could maybe give us some answers on our planet of Earth.
Thank you. Yeah, lovely questions. I might just give a specific example of something I heard from the crew yesterday. My background's in geology and specifically impact cratering, so every time they describe those beautiful basins, I get really excited. They did describe Ohm crater a couple of different times, and they noticed a variety of different color and albedo hues associated not just with Ohm, but with the rays that extend out from the crater. This could indicate, impact impactors, impact events are really compelling for a lot of reasons. Obviously, I'm quite biased, having written my PhD on them. But they can excavate material from great depths below the surface, which means they're kind of like a geologist cheat code, right? Where you can't get all the way down there by yourself, but when an impact has brought up that material for you, it can actually perform that excavation, and we just need to send the crew to the right spots on the surface, and they can actually look at depths far below the surface. And I bring that up here to say that what the crew observed around Ohm yesterday was they actually noticed color and albedo hues coming out in those rays, and they noticed that they were distinct and different and evolved along the ray systems, which could potentially lead us to believe that that crater excavated from distinct depths below the surface of the moon. So it's those kinds of nuanced observations that can ultimately inform future landed missions, future crewed missions, to understand where can we go to maximize the scientific value. These ultimately get at chronology of the solar system, at how the inner solar system has evolved over time, which connects to, the moon being the witness plate for our planet and for the inner solar system. You heard Lori and I the other day get very excited about talking about, pesky plate tectonics and oceans and vegetation that gets in the way of us looking at the early part of our planet's past, and the fact that that part of the record of our Earth-Moon system is still available on Earth. Well, where it's available is the highlands, the far side highlands, and the South Pole. Specifically, the South Pole has the South Pole Aitken Basin, which is my personal favorite lunar and planetary science objective. It's the oldest basin in the solar system. If we can get the right age constraints on that basin, it can help us anchor the chronology for the entire solar system. And so crew observing things like they did with Ohm, where they can say, with my eyes, I can see this distinction, which can ultimately tell us that future observations of high priority landing sites could tell us something similar. This is how we start to really bite away at these really, really fundamental science questions that impact not just our understanding of the moon, but how our own planet has evolved over time.
Mark Kirkman with NSF. This is for Rick. While we have you here, I'd like to drill down a little bit on entry day a little more. Sounds like weather in the primary recovery zone is looking favorable, but can you walk through, as we approach EI and pass EI, what redes capability you have, what kind of cross range and downrange capability you have, when are you committed to that landing zone? And also, with this thermally benign entry you're going to fly, do you still expect to exceed Apollo 10's speed record? I know you don't care about that stuff, but we do.
That's all right. You can still keep asking the questions, and we'll go follow up, and we'll find the answers. I do not have the answer offhand about the Apollo 10 speed record, so we'll have to get that back to you tomorrow. And tomorrow, I'm actually going to provide a lot of detail about the sequence of events for entry, as I'm the entry flight director for Friday evening splashdown. But with respect to your particular question about entry interface, we can select a new landing site as late as entry interface. We would prefer to not do that. We like to give ourselves a little bit of margin, but we can adjust the latitude and longitude of the site, and the spacecraft will fly to those coordinates so long as we get that command up before entry interface. So we're going to make a decision far in advance of entry interface to know where the splashdown site will be, because our top priority is to ensure that when Integrity and her crew of 4 splash down, that we have the recovery forces right nearby to help get them out and get them back to the recovery ship. So we have about a 475 nautical mile range. I can't do that conversion. But 475 miles of ocean within which we can select the most acceptable weather. And as you said, weather near San Diego looks favorable, so I'm optimistic that we'll be able to land close to the shore.
Tom Clark with Sky News in the UK. First of all, congratulations on the flyby and those breathtaking images, and thanks for doing this too. There's been a lot of focus on the toilet, but I'm looking to get a kind of overall perspective on how happy you've been with Orion and the European Service Module. What are you definitely going to have to fix before you fly it again? And how confident are you looking ahead to re-entry?
I'm not sure I heard the end of the question. You talked about how the Orion is performing, and it's performing spectacularly. I have to tell you, our Orion team is so pleased with really everything the way that it's performing. The engines, the manual control that you've heard us talk about several times, that the crew have just gone over and over about how well that's performing, how nicely the Orion crew module is handling. The service module, again, providing everything that we need. Yeah, we've had a couple of challenges, but overall, I mean, I think they're pretty minor in the whole grand scheme of things. The hardware itself performing extremely well. We're really looking forward to turning this around and flying again in a year, and then again a year after that. I think this hardware is really spectacular, and we're really looking forward to doing this more often. We're going to get the toilet figured out. The toilet is actually functioning perfectly. It's the drain, the ability to vent the wastewater. And as Rick said earlier, as soon as we get this down on the ground, we'll be able to get inside, and we will get to the root of that.
Hi, Lisa Grossman from Science News. This is especially for Kelsey, but actually for all of you. The astronauts yesterday used a lot of really fun analogies and descriptors for the features on the moon they were seeing. Did any stand out for you as favorites?
Oh, of like the analogies they used to describe lunar features? Yes. I liked the handprint, and that actually, we had a team working overnight to figure out exactly what they meant. They found it this morning. They were very excited to figure out exactly what they were talking about. I think, we train them, to be totally blunt, we train them to describe it like they see it. Tell us what speaks to you and how you can communicate it back to us. And so I think Christina delivered on that ask when she described a feature as looking like a wound. We do agree. I'm not sure it was my favorite lunar descriptor I heard yesterday, but it was evocative, and she was right. It did indeed look like a wound. And I was also really resonating with the way that several of the crew members were trying to, in the spirit of wanting to have a scientific dialogue, right? They had science questions they were trying to answer, and they were asking us some pretty sophisticated questions real time. And so to bring us with them on what they were seeing, the way that they were cluing us in to how they were moving across the moon by saying, take this feature, draw a line from that to this, and then continue going, and this is the feature we're looking at. Help us use that as a waypoint. It was an incredibly impactful way to have our team be ready to very quickly provide them with answers to the science questions, which is, again, important, not just because, of course, we want to support our crew at the moon, but when we can respond quickly and understand what they're looking at, it maximizes science, because we can immediately ask the follow-up question and have them burrow in even deeper on those multiple working hypotheses. So the descriptions are not just great to clue us into what they're seeing, but it really helps us in real time maximize the science we're getting out of, in this case, a 7-hour flyby.
I'd like to just comment real quickly on one of my favorite. It wasn't actually a lunar observation, but it was during the eclipse, and they were looking at the planets that could be seen. You could see Mercury, Mars, and Saturn.
And Venus, yeah.
And Venus on the other side, yeah. But they're looking at the planets, and I can't remember who said it, said one of them looks kind of red, and Kelsey's observation was, that's Mars, you're looking at your future. And I thought that was spectacular.
Thanks. We only have time for a couple more questions, so I'll pass it over to you, Jonathan, and then we'll do one more.
Thank you. Jonathan Seri with Fox News. I would love to know about the logistics that went into the ship-to-ship call. If you could explain in layman's terms, how did it work out? And perhaps more importantly, what was the symbolic impact of that call?
So the logistics, we have done a number of public affairs events on integrity throughout the mission. We do them multiple times a week on the space station, and everything goes through Houston. So the data comes through the Deep Space Network, through the Jet Propulsion Laboratory over to Houston. We have audio and video technicians here in Mission Control who can reconfigure the routes for the data and send it to the appropriate destination. We do public affairs events down from the ISS through the tracking and data relay satellite system. And so that's something we do all the time. It's just a matter of connecting the two wires. And so logistics were really quite easy despite the distances.
Yeah, maybe I could add too. I was in the flight control room this morning for that call, and something I observed that I didn't anticipate. You know, of course, we're expecting the crew joy at talking and connecting to each other, but looking around the room at the other flight controllers, and actually the viewing gallery was open for other FOD employees to observe. You know, this is a team sport. You know, so many people, thousands of people work to enable this, and seeing the joy on everybody's faces as these two missions flying at the same time had this moment of connection is going to stay with me as a moment of inspiration from this mission.
Yeah, and I would just add, I mean, in terms of it being symbolic, it is certainly a step in the right direction. I mean, it began with a single person in a Mercury spacecraft, and we progressed to 2 spacecraft at one time. I mean, now we've got an international space station while a spacecraft is coming back from the moon. This is progress. We talk a lot about, what is an interesting KPI, the number of people living and working in space. We want to see that number grow. So hopefully in the not too distant future, we've got communication going on between our moon base, their colleagues that are orbiting above them in a lander, relaying back maybe to other colleagues on an international or future commercial space station. These are all steps in the right direction for the exciting future that many of us were probably imagined as children and we're trying to bring into reality.
We're going to do last question.
Hi, Dr. Allison McGraw, Mysterious Meteorites from here in Houston, Texas, for lunar science lead Kelsey Young. Are there going to be any science data available of perhaps the color data for the impact flashes or trajectory directions they came from?
I asked the crew about that this morning. Any color? How long did they last? Where were they? And Reed and Jeremy, as I was talking to them, had their crew tablets out and they were making annotations and sketches on what they saw. You know, they did just report this morning in our conversation that they didn't observe any color to them and that they were very, very brief, but they did provide sketches on whereabout they saw them. And so again, like I said, we're going to use the Lunar Reconnaissance Orbiter to try to, track to those features and try to identify what they saw. Trajectory is going to be hard, but Lunar Reconnaissance Orbiter data can help us pull that out. What we really wanted to do before the crew, splashed down and got distracted with all of the things they're going to be doing here was capture that nuance before it got overcome by a lot of other mission events. So we were able to capture a lot more detail this morning in my conversation with them, and the LRO team is off to the races.
Great. With that, thank you for joining us today for our mission status briefing. We will have another briefing tomorrow. Until then, you can continue to follow along with the mission 24/7 on NASA's YouTube channel, and we will leave you with these beautiful images captured by Integrity.
Good afternoon and welcome back to the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, where teams continue monitoring all systems and the crew aboard the Orion spacecraft, the first flight of humans on this spacecraft. The crew is having a little bit of a quieter day today. They woke up at 10:35 a.m. Central Time this morning, got into their post-sleep period, and then got to talk to the International Space Station crew. Following that brief encounter, they stepped into their post-lunar flyby conference with science lead Kelsey Young. You just saw her in our mission status briefing. Since then, the crew has had some opportunities to speak with their families and exercise a little bit too. We are targeting the RTC-1 burn this afternoon. That's Return Trajectory Correction 1. This helps fine-tune our flight path for Orion and its crew to come splash down on Earth. We are now 3 days, 2 hours, and 9 minutes from our initially targeted splashdown time. You're looking at a visualization of the spacecraft. Now 48,670 miles from the moon and 228,090 miles from Earth, continuing to grow closer. You can keep up with this data at any time by visiting nasa.gov/track-Artemis. Coming up shortly, we expect the crew to have their intermediate burn targeting conference. At that time, the teams will load up the latest burn plans aboard the spacecraft. The burn we're expecting this afternoon will be small, especially in comparison to the translunar injection burn that put us on this trajectory. These trajectory correction burns are using the RCS, or Reaction Control System, thrusters on the spacecraft. Much smaller thrusters with much less power than the OMS, or Orbital Maneuvering System, engine that we used to propel us around the moon and bring us back home. This is a live view from the spacecraft looking at the service module. That large nozzle is the OMS engine. We do not intend to use it again during the mission, having completed that translunar injection burn. We're coming up on the burn conference ahead of today's return trajectory correction burn with the crew members aboard the Orion spacecraft. As you heard Commander Reed Wiseman call down earlier, they have only eaten about 40% of the food allotted to them for this mission. The food the 4 astronauts eat plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities. Let's learn a little bit more about how to eat in space.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? Can you think?
Oh my gosh. That's clever. What do you think? All right, go ahead.
My name is Christina Cook.
And I'm Jeremy Hansen. We're crew members on the Artemis 2 mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day one. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all 4 of us. And so those would be great moments, I think, in our mission to have prepped some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that would be fun.
My name is Xulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and they're like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis 2. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis 2 mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so that it can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
Eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
Go ahead.
Down and to the left, line 17, the DAP load is 3 for burn maneuver.
Go ahead.
In the guidance solutions section, the delta V tote now 1.4 feet per second. The TGO is unchanged at 1.5 seconds.
Good, go ahead.
Attitude, yaw, 154. Pitch, 2.6. Roll, 2.87.
Copy, go ahead.
And the last bit's the delta V, X, minus 1.2, Y, 0.6, Z, minus 0.6.
We copy all. Thanks for that clear read up, and we see that our next step is to run 2-level targeter.
We concur, and we'll be watching. And just a reminder that we're not pressurizing the tanks before this burn, so we're going to do it in blowdown.
Copy blowdown, and understand we have a go to complete step 9 on board, even though the burn execution steps show it as a skip.
Checking. Oh, good catch, Christina. We missed that. That should not say skip. We do want you to do step 9 for intermediate targeting.
Copy all. We will do it and chat with you after. Thank you.
Roger.
That was Capcom's Stan Love here in Mission Control Houston, a fellow NASA astronaut speaking with NASA's Christina Cook aboard the Orion spacecraft. The crew aboard the spacecraft is preparing for their return trajectory correction burn. It's the first of these return trajectory correction burns, reported to be a 1.4 foot per second delta V burn. Again, we are expecting that return trajectory correction burn tonight around 7:03 p.m. Central Time. These small return trajectory correction burns. Houston integrity with that. If you wouldn't mind, just given the rest of the burn execution steps a once-over, we think they all look nominal from here on out, but we'd feel better. Let us know if you see any other deltas. Thank you.
We will run an additional check and call if we find any other problems.
Perfect, thanks. Such a fantastic view coming from a solar array camera on Orion, looking back at all of us here on Earth. Currently, the spacecraft is 227,756 miles away from our home planet. Orion is now 49,168 miles away from the moon. Earlier today, the spacecraft exited the lunar sphere of influence. That's when the pull of gravity is strongest on the spacecraft.
And Integrity Houston for Christina, we have double-checked all of the steps in the pad for the execution, and we found no more mistakes.
You guys rock. Thanks.
And Christina, while we've got you, we have increased the fan speed, and we're wondering if you want us to keep it at this level for the next exercise session.
We feel it, and yes, please.
We will do that. Thank you.
Thank you for that.
This is the Artemis Flight Control Room at Johnson Space Center in Houston, Texas. Current flight director is Jeff Radigan, leading all of the teams around the room, monitoring Orion's systems. This is Flight Day 7, following launch on April 1st of Orion atop the Space Launch System spacecraft at Kennedy Space Center in Florida. This live view is coming from Orion, looking back at all of us on Earth, or should I say looking to all of us on Earth, as that is where the spacecraft is headed following yesterday's lunar flyby.
Integrity Houston for the timeline. Integrity Houston for timeline.
We're live in Artemis Mission Control, and you are looking at a live view of the Earth from the Orion spacecraft. We are now 5 days, 23 hours, and 39 minutes into the Artemis 2 mission, the first flight of humans aboard Orion. The crew aboard the spacecraft has been working on the targeting plan for the upcoming RTC-1 burn. That's Return Trajectory Correction 1, a fine-tuning maneuver to keep us on a straight and narrow path on the way to the Pacific Ocean.
Integrity Houston, voice check, Orion Earth 1.
We have you loud and clear, Stan.
We have you the same. Did you hear 2 earlier calls for timeline about 3 minutes ago?
Negative. Go ahead, those calls again.
Okay. We had just tried to get your attention for some timeline things. It looks like there was some uplink going on elsewhere in the system. We're going to chase that down. For the timeline, can you please give us a status on the RHC install and the docking cam install?
Yeah, we're just processing the docking cam install right this moment. Probably be another 2 minutes before it's up. And we're assuming we need to disregard that. And then the RC, we knew it was in the procedure earlier. It's prepped, not quite up yet, but it's in position, so we're good with the RC.
If you're happy, we're happy, and copy the docking cam. Next, at the end of your midday meal, we've got a scheduled flight director crew conference. The vehicle looks great. We don't think we need that conference, and if you agree, we can cancel.
Okay, crew's good up here. We can go ahead and cancel that.
All right, and finally, we saw your intermediate targeting complete successfully, and solution looks good from here.
Okay, we concur, Stan. Appreciate it.
That's it for now. Enjoy your lunch.
We most certainly will enjoy this very rare lunch out in deep space. Okay, Houston, you can go ahead and check the docking tunnel, making sure you're seeing everything you expect in the camera.
Copy, we'll take a look.
We are live in the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, with a mission elapsed time of 5 days, 23 hours, and 45 minutes into the flight of Orion on Artemis 2, the first flight of humans aboard the Orion spacecraft. We just heard some calls while the teams are planning for the upcoming return trajectory correction burn, and the crew has been given a go to get into their midday meal. Meanwhile, here in the flight control room, I am joined by Trey Perryman. He is the Orion Mission Evaluation Room lead. So thanks for joining us today.
Yeah, good afternoon, Leah.
Tell me a little bit about you and your role.
Sure. During this mission, I'm called the Orion MER lead, the Orion Mission Evaluation Room lead. And so this is a team of engineers, a large team of engineers who have a critical role in the success of this mission. We are responsible for really being the engineering source of knowledge base for the mission. So this is a large team comprised of the engineers who designed, built, assembled this spacecraft, and then processed this with our KSC team members before launch. During the mission itself, we are here in the Mission Control Center. And we provide that expertise to the operational teams, the flight ops team, the launch team, before we lift it off. And my role is to lead this organization, this team of engineers, and then during the mission, report out the findings, the observations we have to our leadership team, to the mission management team and others.
So what's the configuration like in the MER? Is it consoles like this? Are you staffed 24/7? Can you break that down?
Sure, yeah. So the MER itself is really a combination of different functions across the spacecraft.
Monitor off of battery until bedtime.
Copy. Acoustic monitor on batteries, and we have checked and are getting good data from the docking camera. Thanks for that work.
Trey knows the rules, that
That's
we always
right.
let the astronauts talk first.
That's very important. I grew up in. I was telling Leah, I grew up in this room here as a flight controller on the space shuttle program and ISS assembly missions, and so I definitely have learned that protocol. So bear with me as I explain this. But up in the MER, this is a collection of focus areas. So we have different. We call them consoles, just like we have in the flight control room here, and these are really representatives of different engineering functions or expertise. And so we have a console, for example, for the power system, for the propulsion systems, flight software, guidance, navigation, control. And so these people are all, they come together in this one place, and they're comprised of different organizations. So NASA, the ESA, the European Space Agency, and our contractors, Lockheed Martin and the Airbus company. So we have a blended team of engineers who participated in the development of this spacecraft, and now its execution.
Well, tell me a little bit about how the MER works with this front room, because I hear calls, on these back loops about checking with the MER on something. So how does what the team does there inform what the team is doing here?
Yeah, that's an excellent question. In the Artemis program, we are really a combination of many teams. And so the operations team, the flight control team here, and then the Orion MER are different teams, and they play a unique and separate role. So the operations team, just to start there, is responsible to execute the mission. And so they fly the spacecraft, they send commands, they work with the astronauts and plan their day and plan the activities on the spacecraft. For the MER team, we're really focused on truly the engineering depth of knowledge. And so we are following the vehicle systems, monitoring the performance of components, of integrated systems together, the whole spacecraft itself, really to understand how the vehicle is performing, understand it against what we were expecting pre-flight, and then to help when there are anomalous conditions. So sometimes there are things that have gone wrong, as others may have noted here for this mission, it's the MER's role to help the ops team through that. So the operators here in the control center will respond to an issue. It'll be the MER's role to find resolution of that issue over time. So they're unique roles, and we talk and compatible, and so we talk with one another through the mission. So our flight controllers here and the MER consoles talk regularly, every day, all through the shifts, about what's going on in the spacecraft components. And then our team upstairs is led by MER managers, so they're responsible for one shift to the next in the MER. This MER supports round the clock, and just as the flight director does in this room. And so our MER managers and the flight directors coordinate as required.
Well, let's talk about preparation a little bit. So I know that we participate in sims here in the flight control team. How does the MER prepare for a mission like this?
Right, very similarly. So the MER team, we're different than flight controllers. And so where the flight controllers, this is their bread and butter, operations is what they do primarily. The engineers in the MER are also very good because they draw upon their day job of designing and understanding, really qualifying the system, testing, evaluating, improving. And so for the MER team, our training really begins with what we do outside of the mission, pre-flight, ahead of time, and in understanding this vehicle, defining what the vehicle will need to do during the missions. And so when it came to really I think your question is really about how do we actually specifically prepare for this mission. We began in January of last year, and we formed the team and identified who would be on the team, and then participated in dozens of simulations with the launch team out at KSC, and then also here at mini sims with the flight ops team. And so exercising team communication within our own MER team, and also communicating with the flight controllers, communicating with the launch control team. A lot of the simulations we do stress scenarios, which are useful for learning about the systems, but also learning how do we communicate, how do we resolve in a timely manner, how do we understand the condition of the vehicle and make sure that it is ready to continue to fly and successfully return the crew home.
Fantastic. Well, let's talk a little bit about yesterday. So we had Lunar Flyby Day.
Yes.
What was the energy like in the mission evaluation room?
It was a fun day. So, and a day, I think, full of emotions. I think for many who witnessed yesterday, probably around the world, we all shared similar emotions and feelings about the gravity and the momentous occasion that was. when Jeremy was calling down and spoke about those craters and naming those two specific craters, I don't think there was a dry eye in the room. I mean, silence. So most of the team upstairs, like here, are wearing headsets, but we had a lot of extra visitors. So we had speakers on, but you can just hear very clearly Jeremy coming through the speakers we had up there. Very impactful. And then as we approached Paralone, the altitude of closest approach to the lunar surface, lots of excitement. Immense joy as we led up to the Earth set before we went into that eclipse period and loss of signal period. Before launch, the crew members came out and visited the MER and talked with us and gave us patches, those double-sided patches that they decided, where one side is a picture of the Earth with the moon in the distance, and then the other side is different with the moon in close up and then the Earth in the distance. So we did what they had asked us to do. And so at the moment of Paralune, we all had a little ceremony of or activity of flipping the patches. And so immense joy, excitement. It was pretty fun. And then as we knew we would get signal back as Orion continued to fly on the other side of the moon, and we knew we would get comm back with the Earth, intense focus. Really wanted to make sure, what is that vehicle looking like once we got comm back with them.
It sounds like we were going through some similar things in both of these rooms.
I'm sure.
When the craters were named, it was a moment of silence in here as well. It was very, very touching. And we also have those double-sided patches, and we got to show those yesterday on the broadcast, and we had our own moment of getting to turn those around. So it was a very fun day here as well, and I'm glad to hear that you had that in the MER too. So now that we're through Lunar Flyby, we're officially on the journey home. How do you feel about the rest of this mission and coming down and coming to splashdown?
Yeah, this mission is not over until we get the crew back. So the MER team has extreme focus right now. There are a lot of things that the crew members are doing themselves in the cabin to prepare for this journey home, and we are also watching the spacecraft. And it's really mindful that we are.
Houston for smoke detector.
I'm looking at it right now, and it looks good. Stan, what's up?
It is showing us a bunch of noise and spikes. We're wondering if something is bumping against it.
We were just setting up for a photo in the cabin, but I do not think we have hit it. So that would be abnormal. Christina's checking it. There is one charging cable near it that she's re-anchoring now, but nothing is really in the way of that thing.
All right, copy, Reed. Actually, that's a helpful report. We might have been getting some interference with that cable. We'll keep an eye on it.
We just heard a call from the crew aboard Orion, from the Capcom Stan Love here to the crew aboard Orion about potential signal from the smoke detector, and it may have been interference due to a nearby cable, and the team's going to keep their eye on it, but no alarms here. Trey, we were talking about the journey home now that...
And integrity, we are no longer seeing that noise on the smoke detector, so we're suspecting interference from that cable.
Interesting. Okay, thank you.
Just what we were hoping to hear. We were talking about the MER, and now we're on our way home, and the mission is really not over. It's definitely not over until we have the crew back safely. So what's the focus like right there now?
Right. We have a couple of trajectory correction burns coming home, and so the MER team is looking at systems that would be involved in that and the performance of those burns to really make sure we're hitting the right entry interface conditions. I mean, that's really where, for this spacecraft, the rubber meets the road in terms of recovery and returning home. We need to hit that target so that the rest of the spacecraft can go through the Earth's atmosphere, open parachutes, and finally successfully splash down. So the MER team is looking at that. We're worked through a handful of different different anomalous conditions on the spacecraft. I think the crew is doing very hard in the space, working through different things in the spacecraft and their own day, their own schedule. And so we're watching that, but really all eyes towards entry interface.